Hey Earth Science fans, it's Mr. Cole here, and I'm asking, do you believe in aliens? I definitely believe in aliens. And no, I'm not talking about these UFO, visiting Earth kind of aliens. I'm talking about how there just has to be aliens out there somewhere. Estimates say there might be as many as 1 or 2 trillion galaxies in the universe, and each one of those galaxies has hundreds of billions of stars. One estimate I saw from scientists said that there might be as many as 1 septillion planets out there. That's 1 followed by 24 zeros. That's how many planets there could be out there. And you're telling me that not one of those planets besides Earth has alien life? I mean, come on. There has to be alien life out there somewhere. So what would these aliens look like? Would they look like this? Evil T-Rex giraffe style things? Would they look like giant whale lizard slugs? I hope so. That's pretty cool. Anyway, I always think about aliens when I teach this lesson because this lesson is about how the universe is organized. And the universe is, well, huge. Remember to keep up with your thinking rights. You're typing the answer to those questions below, and you can use any resource available to you. It's just to activate your thinking, and I'm not looking for like a perfect right answer. Don't worry about getting them wrong. It's just to activate your thinking on this topic. So in general, the universe is organized from largest to smallest, with the universe at the top, below that galaxies, solar systems, stars, and planet being the smallest denomination that we'll talk about today. All right, so the universe is everything that we know of. That's all of outer space and everything in it. Now, the event that started the universe was the Big Bang, and that happened about 13.8 billion years ago. We're going to learn more about that specifically in a later lesson. We estimate that there's hundreds of billions, if not a trillion or 2 trillion galaxies in the universe. It's expanding. We can see that and measure the speed at which it's expanding in some cases. And this is kind of a little crazy, but some parts of the universe are so far away that we'll never be able to observe them because they're expanding so rapidly that we would never even get the information from that part of the universe, which means we might never know if the universe ends or if it just extends forever. We might never know that because we might not be able to get information from that far away. And some of you out there might be thinking, well, don't scientists now talk about multiple universes or parallel universes? And yeah, it's true. It's actually a theory that's gaining more traction, that maybe our universe is just one of many universes. I saw a theory that inside of each black hole is a gateway to another Big Bang and another universe. That's certainly possible. But for our understanding and for the scope of this lesson, we'll talk about the universe as if that's everything and everything that we know of. So the second largest group or grouping in the universe is called a galaxy. And a galaxy is still pretty huge. It's hundreds of billions of stars. And they're all orbiting a black hole. Most galaxies have a black hole in the center. Until you get the pointer going here. So right in the middle there, if this is an image representing our Milky Way, there'd be a black hole right there in the middle. And so then all of the stars are orbiting or revolving around that huge gravitational center of the black hole. Our galaxy is called the Milky Way. You may have heard of that before. It's just the name given to our galaxy. And our galaxy, the Milky Way, is actually predicted to have a collision with another galaxy. That means they're going to crash into each other in about 4 billion years. So not anytime soon. But we're moving closer and closer towards this other galaxy called Andromeda. Now, since I did mention the collision between the Milky Way and Andromeda, from what I know about it, even though that sounds kind of like catastrophic, there's so much space in a galaxy that as they get closer together, it's not like all the planets are going to smash into each other. They'll probably just pass by each other. But there will be changes in gravitational pull as planets get closer to each other. and the two black holes in the center of each galaxy are going to merge into a supermassive black hole, and then these two galaxies will become one galaxy. Now again, that's maybe 4 billion years away, so we won't see that, but we can predict it, and we can observe that they're moving closer together. Now next, after galaxies and working our way to smaller groupings, we have solar systems. Now a solar system much, much smaller than a galaxy. It's all of the objects that revolve around one or two stars. Now our solar system has one star, and we call it the sun. But many solar systems out there actually have two different suns, and they call them binary systems for the fact that they actually have two stars. Now our solar system is roughly 4.6 billion years old. All the objects came together roughly the same time. The sun was a little bit earlier, but in generally we say our solar system is 4.6 billion years old. Now obviously the solar system includes the sun. It also includes 8 planets and any other rocky or gaseous object that orbits the sun. That's the key. So this could be an asteroid, a comet, a dwarf planet, or a moon. And we're going to learn more about the distinction between those objects in a later lesson. So working our way smaller, we got stars. And stars are the main feature of a solar system. It's what the objects orbit around. Roughly defined, it's a huge ball of gas that radiates light. That's what distinguishes it from a planet. It actually has a very similar composition to large gaseous planets like Jupiter. It's made of hydrogen and helium, but the star is radiating energy and light. And we're going to learn more about that later. Our star is so big that it's the size of 1.3 million Earths, so significantly larger than a planet like ours, a rocky planet, for example. Touched on this, there's nuclear reactions in the star's core that creates light, and that light radiates as energy towards Earth. It's why a star looks bright, and it's why we can see stuff on our planet. So working our way smaller, we have planets, which is defined as a large solar system object that does not create light. So it's different from a star because it's not radiating light. And it could be rocky, like Earth, it's solid, you can stand on it, or it could be made of gas, like Saturn or Jupiter. This is a photograph right here of Saturn that was taken in 2016. It's one of my favorite photographs of all time. Like, that's actually a picture of what Saturn looks like in space. It's just really beautiful, a giant gaseous planet. We'll learn more about the distinctions between planets later. So we got 8 planets. We got Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. And just because I'm sure some people are thinking about it, Pluto was downgraded from planet to dwarf planet, and I know this was a sad day for many of us, but basically what scientists said is that it shares an orbit with many similar sized objects, and so it doesn't get the special designation of planet. It's actually called a dwarf planet. Basically there's hundreds of these dwarf planets in our solar system, and if we were going to include Pluto as a planet, we'd have to include all of these other things. And they wanted planet to be like this special distinction for only these like 8 large special objects called planets. All right, folks, well, that's how we organize our universe from largest to smallest, and just a preview about what all of those objects are. More information to come, and good luck out there.